Hello viewers, welcome to video number 79 of the channel Chemphilic, and video number 79 is the 21st episode of Chemical Thermodynamics. Topic of this episode is comparison between isothermal and adiabatic expansion of an ideal gas. So let's start. So, isothermal expansion of ideal gas. So, this side I am writing isothermal and this side adiabatic. Isothermal expansion means expansion or contraction, but here I have written the topic expansion. That's why I am telling expansion. Isothermal expansion means first point, temperature remains constant. Temperature remains constant. Okay, and second point is next point, heat is absorbed in expansion. But here temperature remains constant means delta T is equal to 0. And here in adiabatic process, adiabatic reversible expansion of ideal gas, here no heat exchange with surrounding. No heat exchange with surrounding. Okay, and temperature changes. Temperature changes. So here Q is equal to 0. Heat absorbed is equal to 0. There is no heat absorbed during expansion. Here we have taken expansion only, so I am telling only about expansion. Now, second point, as temperature is constant, T is constant in isothermal expansion, isothermal reversible expansion, then no change in internal energy. Because you know internal energy is the function of temperature. It indicates the thermal energy. Due to change in internal energy, temperature changes. If temperature is constant, there will be no change in the internal energy. So no change in the internal energy means delta E is equal to 0. Now from first law of thermodynamics, we know that Qp is equal to delta E plus P delta V. That is the pressure volume work done by the gas during expansion, volume expansion. Now delta E0 means Qp is equal to, already you know, that is P delta V. So whatever heat is absorbed, that is completely utilized for doing the pressure volume work. No change in internal energy because temperature remains constant. Now here you see that no heat is absorbed. Now from first law we can write Q is equal to delta E plus P delta V. Here Q is equal to 0 when heat absorbed. I am telling about expansion, that's why I am writing Q absorbed. So heat absorbed is equal to 0 and that is equal to delta E plus P delta V. So therefore this pressure volume work done by the gas at the cost of its own internal energy, because there is no energy from the outside. So, but gas is performing the work. So, to perform the work, it utilizes its own internal energy. Therefore, this internal energy decreases. Internal energy is the function of temperature. So, during expansion means adiabatic expansion, temperature decreases. Temperature decreases. Okay. So, in isothermal expansion, the work is done by the heat absorbed. Whatever heat is absorbed, completely utilized for the work done. And here the work is done at the cost of its, means that the cost of the gas internal energy. So here work of expansion is done at the cost of the internal energy of the gas. Okay. Now, next. Expression of work done. Expression of work done during expansion. Which expansion? Isothermal expansion. Okay. That expression, all of us know that work done by the gas means we'll take the negative sign, that is equal to nRT ln V2 by V1. V2 is the final volume and V1 is the initial volume. And here, in case of, this is the first point, then this is the second point, here first point, second point, and then third point. In adiabatic expansion, that is the expression of work done in adiabatic expansion. That is that W is equal to minus CV dt. Or you can write W is equal to minus CV. Overall, I can write this type of delta, D capital delta. So, W is equal to minus CV T2 minus T1. Final temperature minus initial temperature, because here temperature is changing. Okay. Now coming to the next point, that is the fourth point. So here isothermal and here adiabatic. Now, for isothermal reversible process, this pressure volume relation, what is that? PV is equal to constant. But for adiabatic reversible expansion, this pressure volume relation, that is what? PV to the power gamma is constant. What is gamma? Gamma is equal to Cp by Cv. This is the fourth point. Okay. Now coming to the fifth point. See, we know that Cp is greater than Cv. So, Cp by Cv must be greater than unity. Okay, must be greater than unity. So you see here, in isothermal process, this, for a particular, I'll draw the graph and I'll tell you. See here, this side pressure, volume, this curve is for isothermal, this curve is for adiabatic. Okay, this is iso, this is adiabatic. So what you can observe from this curve? See, if the pressure is decreased from here, little it is decreased this much from here to here, then volume is increasing. How much is the volume increase? Volume increase for adiabatic processes this much, for isothermal processes more. Okay, volume increase for adiabatic process, you have to see from here. I'll draw one line here, then it will be more clear. Volume increase for adiabatic processes this much when pressure is decreased, but isothermal processes more. Why? Because in adiabatic process, PV to the power gamma is constant and gamma is positive. So, for here, fifth point we write that for same decrease in pressure, the increase in volume is less for adiabatic process. Okay, increase in volume is less. And here what I should write? For same decrease in pressure, increase in volume is more. Okay, obviously here PV is constant, but here PV to the power gamma is constant. Okay, suppose here P is 1, just imagine P is 1, V is, here it is say 4. Okay, or V here it is, say it is 2. Okay, so 1 into 2, that is the constant. But here what it will be? 1 into square root of 2, because suppose gamma is 2, then it will be square root of 2. So, for same decrease in pressure, volume increase will be more. Okay. So, this is for isothermal process, and volume increase is less for adiabatic process. This part we can explain in other way also. See here, in adiabatic process, no heat is absorbed. Adiabatic reversible expansion, no heat is absorbed. Then work is done. Work of expansion is done by using the internal energy of the gas. So, internal energy decreases, already I told you. And internal energy is the function of temperature. So, temperature decreases. Okay. As the temperature decreases, that makes some shrinkage in the volume. Whatever volume expansion, some shrinkage will occur. So, overall volume expansion will be less. Okay. Internal energy decreases, so temperature decreases. As the temperature decreases, so because of the fall in temperature, there will be some shrinkage in the volume. So that's why volume increase due to same decrease in pressure is less in adiabatic, more in isothermal. Now, coming to the last point, from here itself I can explain, that is the work done in isothermal reversible expansion is more. Obviously, because volume increase is more. And here work done in adiabatic reversible expansion is less than isothermal process. Okay, that means work done in isothermal process. See, here also you can understand that one. Work done means the area under the pressure volume curve. Now, area under this pressure volume curve for adiabatic is this much. This is the area. But for isothermal means this overall. That means for isothermal it will be full. The red one is for isothermal. So area under this curve is more. So for isothermal process, this area under pressure volume curve is more. So work done is more. Okay. Here I can see that area under pressure volume curve is more for isothermal process. Therefore, W also more, work done also more. And here what we are observing, this area means only this dash by green color, this area. So here area under pressure volume curve is less. Therefore, work done W also less. That we can observe it. So, these are the comparison between isothermal reversible expansion and adiabatic reversible expansion. Isothermal process, temperature remains constant, and adiabatic process, no heat exchange. Here, there the temperature changes. In isothermal process, no change in the internal energy, but adiabatic expansion work is done at the cost of the internal energy. So, internal energy decreases, so temperature decreases. Then, expression for the work done for isothermal process, that is nRT ln V2 by V1. For adiabatic process, it is minus Cv dt, that is T2 minus T1. For isothermal process, pressure volume relation in reversible isothermal expansion, that is PV is equal to constant, but for adiabatic, PV to the power gamma is constant. Now, as Cp is greater than Cv, so Cp by Cv, which is nothing but is equal to gamma. Cp by Cv, which is nothing but is equal to gamma, that is more than 1. So, for same decrease in pressure, increase in volume is more in isothermal process than adiabatic process. And work done in isothermal process is more compared to adiabatic process. And the most important one, the isothermal process, temperature changes, extremely sorry, isothermal process, temperature remains constant. There is no change in the temperature, but for adiabatic process, temperature changes. So these are the comparison differences between isothermal and adiabatic expansion. Thank you.